Hi, this is Solving Trigonometric Equations by Carley,
Hanna,
McKenna, and Haley.
from period 8. So, solving trigonometric equations involves skills from the unit circle and knowing the sine and cosine, tangent, all the different functions and the angles, and you need to know the Pythagorean identities and solving equations in general, stuff from like algebra, how to isolate variables. Okay, so we're going to start off with a fairly easy problem. Cosecant x plus 2 equals 0. So notice how I boxed the cosecant x, because in algebraic equations you isolate the variable, but in trigonometric equations you are isolating the whole trigonometric function. So what we are going to do first is we are going to subtract the 2 from both sides. So then it becomes cosecant x equals -2. So notice how we're solving this like an algebraic equation. Okay, so you don't really know off the top of your head what angle has a cosecant of like what angle has what this angle will be. So we're going to change it to its reciprocal, so which is sine. So when you have to change one side to its reciprocal, you have to make the other side its reciprocal. So it becomes sine of x equals -1/2. So you changed the -2 to its reciprocal, -1/2, and then you changed the cosecant of x, its reciprocal, as sine over x. Okay, so you know the angles that have -1/2 as a sine. So you can do the trick. All students take classes. So all the functions have positive. All their functions are positive in the first quadrant. Sine is positive in the second, tangent in the third, cosine in the fourth. So you do the reciprocals that follow their same function. So an angle with sine of -1/2 includes 7 pi over 6 and 11 pi over 6, both in the third and fourth quadrant, because that's where sine is negative. There was no restrictions when making this problem, meaning that the answer is 7 pi over 6 and 11 pi over 6. That you can go infinitely many times around the circle and still reach those angles. So to write that, you would do plus 2 pi k, where k is an integer. But if the problem had this in it, x is in between 0 and if x is in between 0 and 2 pi, then you would just write the answers 7 pi over 6 and 11 pi over 6, and you would not write 2 pi plus 2 pi k, where k is an integer. So depending on what the problem says is what you're going to do. So if there's no restrictions, you write plus 2 pi k, but if there is restrictions, this is the restriction, you would just write the two answers. Okay, so that concludes the introduction. We're going to go over some more different types of problems.
Okay, so here I'm going to introduce functions of multiple angles. So we'll start out with a problem like this. And this is the multiple angles. Okay, so like any other problem, you would add 2 to both sides. So you have 4 cosine to the 2 of 2x equals 2. Then you will divide by 4. So you have cosine to 2 of 2x equals 1/2. Next, you would take the square root of each side. So it would be cosine of 2x equals 1 over the square root of 2. Now we know that we can't have square roots in the denominator, so you would multiply that by the square root of 2 and 1 by the square root of 2 to get cosine of 2x equals the square root of 2 over 2. Remember that it has to be plus or minus when you do the square root of both sides. Okay, now to answer this, we're going to let p equal 2x. So that way we have cosine of p equals plus or minus the square root of 2 over 2. So now here, p would equal pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. However, this is just also going around one time, but however, p equals 2x, so that means we have to go around twice. So that would also include 9 pi divided by 4, 13 pi divided by 4, 11 pi divided by 4, and 15 pi divided by 4. Now this is still 2x, so we have to divide by 2 on both sides. So that would make it pi over 8, 3 pi over 8, 5 pi over 8, and so on.
And that is how you do problems where you have to let p equal a double angle formula. Here are the answers to the previous problem.
So I'm going to introduce how to square and convert to quadratic functions and check for extraneous solutions. And remember to always check for extraneous solutions when you're squaring, because you're introducing new solutions and you want to check for